Hello together. In the last video we programmed the temperature sensor MCP9808 and we read out the temperature every second. This is not the typical use case. Normally the temperature you read out mostly every 5 minutes or every 1 hour. And when you're having more sensors reading out, sometimes there are different time interval or you have another task to do. And the question is how to handle this with Zephyr. We are having our structures that we're having our main function. The main function is building our own thread in Zephyr. So it's running independent from the system threads, and we just let in the while loop the thread sleeping for 1 second in this use case. And so we read out the temperature every second. This is quite okay, it's working quite well, and when you're having only one schedule it's easier to handle. The question is how we're making it with more, or when we're having different time intervals to handle. For this, Zephyr having timer and also something which is called work queue. We will handle this in this video. And when we mention thread here, we don't mean in this video OpenThread. We are meaning thread in the topic of multithreading and task handling and so on. So OpenThread and the network techniques thread we will handle in a later video. To implement a timer is actually not very difficult in Zephyr. First, we make a copy from our last project, the MCP example. You can also start with a blank example, but since we need later source code and I don't want to write it again, we're using this as starting point. So, like normal, we delete also the build here, and then we're adding it in our to our projects here. Afterwards you're building the build configuration. And then we open our main function, always checking that you have here the right project selected, the main function, the other you close. And you're seeing here again our sleep timer K millisleep, which we used before. In this case we are implementing a timer. For a timer we are needing a callback function, which is called when the timer is expired. We just define the callback function here. There we do something, we will implement this a little bit later. Then afterwards we're needing a variable from type struct type ktimer. This structure, we will take a look at it, has a few parameters. And the most important are the expiry function and the stop function. The expiry function is called when the timer is expired, and the stop function when it's called via the ktimer stop function, so when it's manually stopped. But we will not use this, we will just use the expiry function. And after this we have to use the function ktimer_init. That the parameters are set at our myTimer variable. So the ktimer_init just takes our timer and the two callback functions. In our case, myTimer callback, which is called when the timer is expired, and the third parameter we set to null because we don't want to have the stop function. And what the ktimer_init does is just to set mostly the expiry function callback and the stop function callback. It's not much more. Afterwards we can start the timer over the function kTimerStart. This function has also 3 parameters. Our timer, then the first timer is delay, and the second is interval. So when we don't want that the timer starts directly, also after, let's say we want a timer every 2 seconds, then we can make a delay 2 seconds, and the first time needs 2 seconds until the timer is expired, and the third parameter is in the duration of the intervals. Then every 2 seconds timer will be expired. We can set this also different. So when we want the timer starting the first time after 5 seconds and then every 1 minute, we can also set this here. And now we have to implement what's happened. We just want to let the LED blinking at this time. So I just copy there. We had this already in another video. We define our node for the LED 0. Also we have to include the GPIO library. And afterwards we are setting the pin as output, the GPIO pin. And in our callback function we just toggle the LED. So now we compile this. Flash this to our board. I mean, the MCP is still connected, yeah, so the whole other things in this function will still be called, so the sensor will be read out also. We can open this here for checking it. See the temperature here, and when we are looking at the camera for our sensor, for our developer board, we're seeing here that the LED is also blinking every 2 seconds, yeah, and the temperature is rising up. Now we can come to the idea to put the whole sensor code into the callback from the timer. We will try this. For this we first writing a function and put the whole code there inside. So MCP 9808 read function. Copy and paste this here. So we're checking again if the device is ready. This while was from the main. So do while we don't need anymore since we are in a function here. So when there is an error, we can always go out from the function with an return. So, and then we just delete the code here. Just let the while loop with the k-sleep timer and put the function here inside, checking if our function is working. So we build it and flash it directly. So, and we're seeing the function is working, still the temperature changing. So the function works well, and when we don't make the function now in the while loop, we make it in the timer callback function. We would expect that it's still working, and let's see what's happened. And you're seeing, nothing what we wanted is happen. We get here an error, so a fetch fail. This is because the callback from a timer is done with the interrupt service routine, and they should be run as short as possible, since it's at the interrupt level and it disturbs the whole working of the Zephyr OS when we're doing it on this way. When we're having a task which takes a little bit longer, especially writing something on the I²C-bus, takes a little bit longer, then we have to do it on another way. So we put it on a queue, on a work queue it's called, and then on the timer callback we just put something on this work queue. So how does a work queue work? It's actually not so difficult. So we define again work callbacks. This is a function where we're having some work inside. So I exchange the name here, and also the head of the function. There is then a parameter. We don't need this parameter, but if we need information or something, we can take it out from the struct car work. But actually, I don't know when this is really necessary. So we put the whole code in this function, and now we have to define a structure which is called kwork. And into the kwork, we are actually having in this structure. Take a look at this structure here. We're having a handler, so this will be the callback function, and the rest here in the structure from a kwork is just for internal use. So there is a flag parameter where you can see at which status the work is and so on. And to which work queue we put it. There can be a different work queues. We are using here now the system work queue. It's the easiest one because we don't have to define something. There is also a delay work which we can define and put on the work queue, so it's not necessary that it's going as fast as possible. And we can define the user work queue, which is normally the preferred way, but for this solution and for our thing it's enough when we're using the system work queue. And for this we're having then also to init work, so MCP 9808 work. We have to initialize, and what is just done is that mostly done is that the handler is set here, so to our callback function. And when this is done, we can, every time we want, we can put this work into the system work queue. And this is just done with kwork submit. So instead of calling here the MCP read before, we just put the work on the work queue. And this is all actually. So we build it. Okay, here we have, of course, also to making a pointer. So we build it, and then we flash it. And we connect to our board, and we're seeing that now we're getting the temperature again. So we just put it in a kind of queue, and then everything works fine. Here we have now the system work queue. There are sometimes system work to do, so we have to be also a little bit careful that we don't put something on it which takes too long or disturbing the whole process. When we're having a task like this, it's better, a work like this, it's better to building up our own work queue. And own work queue is actually an own thread. And for this we have to reserve resources or a little bit space and so on, and then this work queue runs in an own thread and doesn't disturb anything. It's just a little bit more complicated, and for us at the moment not so important. Now we want to clean up a little bit the code. I make it here with kwork init and ktimer init, that we understand a little bit the concept of the variables here. They are actually a much easier way to define this via macros. We use it already before. A lot of times macro, and this is typical in Zephyr. Yeah? So we just using instead the macro, the structure will be directly defined, and also the callback will be directly set here. So we can delete the kwork init here. And with the timer is actually the same. We have here ktimer defined, so we don't have to define our struct by our own, and also not to initialize the timer. And you're seeing it's looking directly a little bit more clean, the code. And we just compile it. And flash it to our board. And seeing that it's still working. Yeah? Everything like what we want. We can put as many works or define it as many works as we want. It depends also only on the resources which are available. Yeah, it's actually not so difficult, but we have to know how it's working. So when we want to make it a little bit more stable and clean, that we don't have any interference with the whole system work queue or something, we can just define our own work queue. It's actually also not so difficult. For this we define our stack size from our thread and the priority from our work queue, the works which we put there inside. Then we define the stack, the thread, and our work queue structure. And now we have to initialize the work queue. And we initialize this in the main function. So work queue init, so my work queue just initialize, and afterwards we are starting the work queue. With the parameter, my stack area, so which thread it belongs to, the size of the thread and the priority. And afterwards we can just put something on this work queue. So instead of submitting it to the system work queue, we just add our work to our own work queue. And then it's independent, and we can change also the priority from the work. Compile it, we flash it. Yeah. And we're seeing that this is also working. This is actually the better solution, but for fast implementation, the system work queue is also enough. Yeah? And we have to take care that the size, of course, is enough when we are having too much works to put on it, which are bigger, then of course the stack size may not be sufficient. We have to increase it then and so on. But for our small task here, it's enough space. When you are having different work to do in your applications, and this is actually a quite good solution, we have also threads in Zephyr. But with threads you really defined like an own program which are separate. When they don't have to communicate with each other, it making sense, but it's really like you're having two programs which are running parallel. They can exchange data, but it's a little bit difficult, and makes sense like we're having network things to do there and reading out sensors there. Like OpenThread or something will be working in a separate thread. But for the most use cases, we would always use work use only. With the timing, yeah, I can actually not 100% say how it is when you're having really something time sensitive. I mean, the timer already, it's just guaranteed that the timer waits at least this time, but since there are underlying things sometimes happen, cannot be sure. And when you're having something in the work queue, the delay can be there, but normally we are talking about really a small time amount, yeah, milliseconds or something like this. So when you're reading out sensor data, if it's after 1 minute or 1 minute and 1 millisecond, I think it's not important. But for a few application, yeah, maybe you have then to find another solution. And I didn't try out when you're needing a lot of sensor data, like for an accelerometer or something like a 9-axis sensor, an IMU, where you're needing at least 10 hertz or something like this. If this is still working well, I guess so, but I don't have the experience yet. This was the introduction into the timer and the work queue in Zephyr and how you can schedule something. Of course, especially in Zephyr, there are different ways to schedule something. You can also use event handling, and also with the timers you could handle it different. You could, for example, not use a work queue, you just using timer and don't use a callback. You're using here the sleep function and let it sleep always 1 second, and you have to do something after 5 minutes. Then you make your timer for 5 minutes and you're asking out the timer if it's expired, and when the timer is expired you're running this kind of code here, and with the second timer you can run different codes. Then, for example, yeah, you're checking then if the other timer is expired. So when you're checking here every 1 second, then your time accuracy is then of course 1 second, at least nearly. Yeah. So I hope it was all understandable, and if you like the video, don't forget to push the like button, and see you in the next video.